When you first boot the Arch ISO, you'll be presented with this terminal interface. It'll give you some information of where to find the Arch installation guide and some information of how to connect to your network via Wi-Fi or Ethernet or others. I apologize for the small text here, but I'm running this in a virtual machine to show you because it's easier than connecting a hardware device to the computer and trying to get the display there. I will try to zoom to text in post, but this is the largest I can create it on the machine live. The first thing you'll want to do is set your locale. So you can do locale ccl list keymaps, and that'll show you all of the key maps and languages available that you can use. I am going to use the US key map, so I'll do load keys US. But you should use the key map that's best for you. Next, you should verify that this machine is booted in EFI mode, because that's where I'm going to be covering with you here. If the machine is booted in EFI mode, this sys firmware EFI firmware platform size file will exist, and it should output 64 for 64-bit. If this file doesn't exist, that means you're booted into BIOS, and that's not what I'm covering in this video, so you should either boot into EFI or find another tutorial to use BIOS. Next, you should verify that you're connected to the internet. You can do that by running IPA, and you'll either see your link devices already connected or disconnected. If they're disconnected, you need to follow the instructions on the Arch Wiki to do that, probably because you're using Wi-Fi, but in this case, I have an Ethernet connection because I'm running in a virtual machine, so it's as if I'm plugged in to the Ethernet network. I can ping archlinux.org to verify my network connection. You'll also want to make sure that your time is correct, because when you go to install packages to install Arch Linux, you'll want to make sure that you're using the correct time. Otherwise, you can run into errors. You could change the time zone here. As you see that I'm using UTC, I could change it to America, New York, but there's no point in doing that because that'll just affect the live installation and not the actual Arch installation that I'm going to use. From here, we'll have to partition the disks so that we can actually have partitions and file systems and such to install Arch Linux. So I will see what disks I have available by running lsblk. I see that I have one dev SDA disk here of size 32 gigabytes. That is my virtual disk that is for this virtual machine. That's the disk I'm going to be partitioning so I can use for my Arch Linux installation. I'm going to use gdisk here. So I'll do gdisk dev SDA, and that'll put me into gdisk's UI. I can run p for print, and you can see that this disk is completely empty right now. So I want to create two partitions. So the first partition, I'll type n to create a new partition. I'll use the default partition of 1. I'll use the default for sector, and then I'll type plus for G, capital G, to make that partition size 4 gigabytes. And the partition code will be EF00 for EFI system partition. At this point, if I run P again, you'll see that I have one partition of size 4 gigabytes, and it's an EFI system partition. I'll run N to create a new partition, accept the default of 2, accept the first sector, and accept the last sector to use the full remaining size of the hard drive. For the hex code here, I'll do 8309 because that'll be Linux LUKS, which is the encryption. So we're saying that this partition is going to be used for encryption. If I do P again, you'll see that I now have my two partitions, one of size 4 gigabytes, which will hold my bootloader and my Linux kernels, and that'll be clear text so that the bootloader can read all those files and then know how to decrypt the encrypted root partition to boot my system. The second partition will be that encrypted root partition, that holding my Linux system and my data. All of these changes are good, so you can run W to write them, and then type Y for yes. And now disks have been partitioned. Even though we have partitions, we don't have file systems or encrypted devices. So we can see the partitions we have here, dev SDA1 and dev SDA2. The first thing we'll want to do is create an encrypted partition or encrypted device using crypt setup LUKS format and point it at the second partition. This will say, hey, this is a destructive operation. Be sure you're pointing to the correct partition. If you are, type yes, and it'll prompt you for a passphrase. You'll want to make sure that you'll remember this passphrase because you'll need it on every boot of the machine. So be sure to enter a passphrase that you will remember to type in every boot. Once that encrypted device has been created, you'll have to open it up. You have to decrypt the device and open it so you can access its decrypted form to store data. So we'll do crypt setup open, point it to the second partition, and give it a name called root so that we can refer to this open encrypted partition by a more simple name. So it'll ask for my passphrase, and now that is open. And that name that I give it is important because now I have a device at dev mapper root, because that's what I've called the encrypted device that I've opened. I called it root. So that's the device I can use now to make file systems and to read and write data. Dev mapper root. Let's create a file system. So I'll do mkfs ext4, and I'll point it at dev mapper root to create my ext4 file system for my root Linux file system. Now I can test that this all works by running mount dev mapper root, mount that at /mount. And if that works, things are looking great. But let's kind of verify the whole chain. Let's start from scratch. So we'll unmount that running umount. And then we will close the crypt setup device, right? The encrypted device. We'll close the root device. So now we've created it, we've tested it once, but I want to close it and test it again. So now let's run crypt setup open, point it at dev sda2 root. It's asking my passphrase again, so I can give it my passphrase. And now I can run mount dev mapper root and point it at /mount. Perfect. That looks great. And the reason why I did it twice, so to speak, is because I want to just make sure that when the system does reboot and go through this process, it's going to do the same thing I did here, right? It's going to have nothing, and it's going to open the device. It's going to mount the device. And I want to just make sure that that whole thing works start to end. We'll also need, though, a boot partition. So we'll want to go ahead and create the file system on our boot partition in addition to the root partition that we just did. So we know that the dev sda1 device is going to be the boot partition. So let's do mkfs.fat, and then we'll do -f32 for a FAT32 file system. EFI partitions or boot partitions need to be F32, FAT32, and I've pointed at dev sda1. Now the file system is there, and I'll also want to mount that to /mount/boot. So I'll do mount make dir dev sda1 mount /boot. Now I have both the root file system mounted at /mount and the boot partition mounted at mount/boot. At this point, we're ready to install Arch Linux packages and get our installation underway. First, you'll want to verify the mirror list that's in etc pacman.d mirror list, because this contains the mirrors that the installer is going to pull from to get its packages. Now, the default list that's generated is pretty good. I personally tend to regenerate it with mirrors that are in my country using HTTPS and have a good speed, but the default mirrors are usually pretty fine for most installations. Now, we'll need to install the proper packages to get this installation underway, and we can do that with pacstrap. So pacstrap-K, we need to tell it where to install the packages. So we're going to install it into that /mount location where we put our root file system. We're going to need the base package. We're going to need the Linux kernel. We're going to need the Linux kernel firmware. We're going to need AMD Ucode because I'm running on an AMD chip. And you can also put additional packages here if you'd like, but I like to keep this pretty slim. But a couple packages that I will recommend is some text editor, some terminal text editor. This can be Vim, this can be whatever you'd like. For me, it's going to be Helix. And I also am going to do Network Manager because I need some network device or some network management solution so that when my Arch machine boots, it has networking. Because I have networking right now in my live system here, but I don't have it in my actual Arch system. So that's a common mistake that people do is they forget to install some network management system. So be sure you do that either here or when we root in a little bit. Next, we'll want to tell Arch Linux how to mount the disks every boot. We do that by updating the file system table configuration. And there's a helper here that we can use called genfstab. -U tells it to use UUIDs. /mount says to where the find mounts. And /mount /etc/fs tab tells it where to write the mounts. And if we just take a look at that file, mount etc fs tab, you'll see there's two mounts defined here. There's mounting the root file system, and then there's mounting the boot partition. At this point, we're ready to change into the Arch installation itself. We've been booted into the live installation this whole time, and we've installed our actual Arch installation into /mount. We could actually chroot into there and change our root into our actual Arch installation. So we could run arch-chroot /mount, and now we are in our Arch Linux installation. The first thing you'll want to do in your new Arch Linux installation is set your time zone correctly. So we will create a symlink to the correct time zone. So for me, it's America, New York, and that'll be a symlink to etc local time. Then you'll want to run hardware clock sys to HC to just set the hardware clock. On a virtual machine like me, this is probably not important, but if you're installing Arch Linux on physical hardware, you would want to run that step. Next, you'll want to edit the etc locale gen file, and you'll want to uncomment the language that you want to use. So for me, it's EN/US UTF-8 because I want to use the English language from the United States and the UTF-8 encoding. Once you uncomment one of those, you can run locale gen to generate that locale. And then you can edit the etc locale.conf file and create lang equal en us.utf8, which is the locale that you've configured. You'll also want to edit the etc vconsole.conf file and set your keymap here. And for me, that's keymap US because that'll be the keymap you use for virtual consoles. You'll also want to set your hostname. So you can edit the etc hostname file and type your hostname in there and save that. At this point, you'll want to install network management software. I've already done that when I passed it to Packstrap, but if you don't install network management software right now, when you reboot into your actual Arch Linux installation, you won't be able to connect to the network. So if I ran pacman-s network manager, that'll try to install the network manager network management software, but it's already installed and it's going to prompt me to reinstall it, which I'm not going to do. But it's super important to install your network management software now, so that way when you reboot, you have network access. And it's not just installing the package. I also have to enable the actual services to start on boot. So I'll do system control enable, perfect. And now my network manager service is ready for when I reboot into my Arch Linux installation. When Arch Linux boots, it's going to load the initial RAM file system or Initramfs, and that needs to be configured to tell the system how to boot correctly, right? What sort of system management solution are you using? In our case, it's systemd. Are you using any encryption, and so on and so forth? So I need to configure that. So I will edit the etc mkinit cpio.conf file, and there's a hooks line in here that you'll want to edit. Now we're using systemd, so I can change udev to systemd. I can get rid of keymap, and I can get rid of console font and change that to SD vconsole, because there was vconsole config that we use for our virtual console. And then I can add the SD encrypt hook because we're using encrypted file system and we need to tell systemd how to deal with that. Once all those hooks are added, you can save and quit that file. And then you can regenerate the initramfs by using mkinit cpio-P. And this will run through all those hooks and say, hey, I'm going to regenerate all of the initramfs files. If there's errors here, you'll know and you should stop and fix them. But if this all goes through successfully, you're all good. At this point, it's a good idea to set the password for your root user. That way, when you reboot into your Arch Linux installation, you're not locked out. I'm also going to create a new non-root user using the shell bash shell and name it sudo Mateo. And then I will actually update the password for that non-root user as well. So that way I have a root user and a non-root user. The last step here is to install a bootloader before we're ready to boot. So I will run bootctl install, and that'll install the systemd bootloader, the system deboot bootloader, to my system. But even though it's installed, I actually have to configure this bootloader too. So I will run helix or whatever text editor you installed, and I'll create a new bootloader entry called arch.conf in /boot/loader/entries arch.conf. And here I need to actually configure this bootloader entry. So I'll give it a title. So I'll call this bootloader entry arch Linux. I need to tell it where to find the Linux kernel. And this is going to be in relation to the /boot location, but I like to use the autocomplete here of my editor to find it. But you don't leave this prefix here because it's going to start at the /boot location. So you don't need to put it here. Then you need to tell it to find the Initramfs. So also same idea, that is in location to the boot location. So I don't need to use the prefix /boot here. I'm just using it to let my editor autocomplete for me. And then I need to pass some boot options. And the boot options here are to tell the Linux system, hey, what does the bootloader need to know in order to boot Linux correctly? And we really only need one option here. We need to tell it how to, what encryption device we have and how to actually decrypt it. So we'll use the rd LUKS name option, and we'll have to give this a UUID of our disk. So we'll do lsblk-f here, and we'll grab that UUID. Perfect. Get rid of all that. And now we have the UUID. And we need to give that disk a name, right? Because before when we did crypt setup open, we gave it the actual device to use and we gave it a name of what to call it. And we'll still call it root. And then we'll tell it where to actually mount. So this will be dev mapper root. Now, this bootloader has all the information it needs to boot the system. It has the title of the boot entry, it has where to find the Linux kernel, where to find the Initramfs, and how to work with that encrypted partition that we've created. You can save and quit this, and the bootloader configuration is finished. And now we're ready to reboot this system and see if all our installation was successful. So we can exit out of that chroot environment. We can also unmount the root file system and the boot file system that we've created. And at this point, we can actually reboot the system. So I will type reboot and let the system reboot. Now for me, it's rebooting back into the USB drive that I had attached, right, the ISO. And for you, it probably won't if you're doing it on physical hardware, but I will fix this for the VM by stopping the VM, going into the settings, removing that DVD drive, and ensuring that my actual, apply that, and ensuring that and go back in there again, that my hard drive is appearing before any other boot devices. With those changes, I can actually start my VM again, and now I'm booting into Arch Linux. If everything went successfully, Arch Linux should prompt you for your passphrase for your encrypted device. So I will give it the password. And if it all went successful, it should boot correctly and prompt you to log in. Now I'm going to log in as the root user here because I want to do some more setup before I'm ready. If all of the setup I've done so far was correct, I should have a network connection still, which I do, which is great. Now, I need more than this terminal environment though. This is great. I'm booted into Arch Linux. This is amazing, but I don't really have a desktop environment, right? I don't have a GUI. So I will install the GUI that I use. So I'll do sudo pacman, or I don't even need sudo. I'll do pacman-s cosmic. And this is the actual environment that I use. I use Cosmic. So I will use the default and let that go through. And then for this optional dependency for the Radeon graphics, I will let it do number 7, Vulkan Radeon. Say yes, and let that install. Once Cosmic is installed, I need to tell it how to start itself on boot because it needs to greet me with its UI. So I will do systemctl enable and then cosmic greeter.service. Now, every time I reboot, the cosmic greeter will be what I see to log in. And before I reboot this machine one more time, I want to install something that I need, and that is sudo, because I want to be able to use my non-root user instead of my root user. So I will install the sudo package, and then I will configure my non-root user. So I'll do user mod -a-G, put my non-root user in the wheel group. The wheel group is kind of just an administrator group. It's a de facto standard in Linux. And then I will actually edit the sudoers file using vsudo, and I have to pass an editor because I'm using Helix and not some Vim or something else. And here I will search for wheel and uncomment this one that says wheel all to allow my user to use sudo, but require a password for it. And now I've fully configured this Arch Linux system, at least to a point where it's going to give me a nice UI when I reboot now. So let's go ahead and reboot this. And we will now see that it prompts again for the encrypted password. But now when it boots, no longer will I just be thrown into some terminal. I will be presented with Cosmic, and I can log in as the root user or as my actual non-root user that you see here, sudo Mateo. And I can type my password in, and boom, I am logged in to a desktop environment as a non-root user. What I personally like about Cosmic, though, just to give you a little tour, is I like its capabilities of like tiling. It's kind of a mix between i3 Hyperland and GNOME, right, or GNOME. You can kind of actually configure this to be like a floating window system or a tiling window system. But if you turn on tiling, it's really nice because now as you open things, so let's open like files and let's open, I don't know, settings. They just float right next to each other and you can bounce between them really easily, move things to different workspaces, move them around. And it's really, really nice. I like this sort of setup here. And there's even more settings that you can do. So if you actually go into the window management, you can configure this and you can configure how you want window management to work, how you want workspaces to work, right? So you can have different vertical or horizontal workspaces. I don't know why it defaults to vertical. I like horizontal workspaces so that I can do this and put things on different workspaces and then move back and forth. This is the setup I use and I love it. I mean, it takes some getting used to because a lot of people aren't used to tiling window managers and there's still way more to configure than I showed you here. But this is my Arch Linux setup. I don't do too much beyond this, honestly. And I hope you find what works for you and get it going.